We'll do move. So normal move statement, okay. So normal move statement you already know.
Oh,
Can you see
ah,
my screen?
yes.
This is a program. I have taken two variables, WSA, WSB.
Hmm.
WSB has a value
Okay.
x of 12, value hello world, WSB x of 12. So I want to evaluate the value for WSB. Initialize WSB, move WSA to WSB, display WSB. Okay.
Oh,
Now I have written move WSA to WSB, then display WSB. So what this move statement we have already used. This is a normal normal statement only. We always move something to something means the value you are moving. You can move a string also, or you can move a value of a variable. When you move WSA to WSB, it means the value of WSA is getting moved to WSB. So when I display WSB, the value of WSB also becomes hello world.
oh,
So let me first compile it. It's easy only. See, hello world value is hello world.
ah,
It's not required. This is required. This is called reference modification. This is very, very important. Now you can see there's a variable WSA, picture clause X of 18, value IBM mainframe 2024. Okay. Now this variable has three words actually. IBM mainframe 2024. You want to split them into three different variables. IBM into one variable, mainframe into another variable, 2024 into another variable. For that, I have taken three variables: b x of 3, c x of 9, d x of 4. Now I have initialized all three of them, b, c, and d. Then I have written move WSA 1 is to 3 to WSB, move WSA 5 is to 9 to WSC, move WSA 15 is to 4 to WSD. Okay.
okay.
So WSA is IBM mainframe 2024. So when I have written move WSA 1 is to 3, it means from the first position of WSA, and 3 means length 3. So from here to
Oh,
here. Okay. First is the position, starting
okay.
position. Next is the length to WSB. Move WSA 5 is to 9 means from fifth position. First position, second, third, fourth, fifth. And length is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Move 5 is to 9 to WSC. Then 2024, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is to 4 to WSD. So
Ah,
this way you can split starting position plus the is to length. So when you display all three of these variables, the output will come.
oh,
Now to compile this program, to execute this program, WSB is IBM, C is mainframe, D is 2024. Okay,
Okay.
this is called
Yeah.
move statement. Okay, now
Yeah.
did we discuss redefines?
Oh, no, not yet.
So I've taken a program, taken a variable W as hello1, x of 10 value mainframes. Then W as hello2 redefines W as hello1 value x of 3. Do you know the meaning of this? What exactly it means actually? When there are two variables, okay? Suppose WSA picture clause x of 10 and WSB picture clause x of 3. How many bytes system allocates for WSA? How many bytes system allocates for WSB?
10, 7, sorry.
Hmm?
For A, 10 bytes,
For A 10 bytes and for B?
3 bytes.
So total 13 bytes, right?
Uh-huh.
Because these two variables are mutually exclusive. These are not dependent on each other. These are separate variables. So for WSA, there are 10 bytes. For WSB, there are 3 bytes. But there are some cases
Okay.
where you can use the memory of one variable. Okay. Like WS
Okay.
hello1 has a length x of 10. And out of 10, you can use some spaces, some bytes or some memories by another variable. So WS hello1 x of 10, WS hello2 can use some of this from L1. So WSL2 redefines WSL1 for x of 3. Now, since it is x, x means alphanumeric. Alphanumeric is left justified. From left hand side, it starts. So from the left hand
Uh,
side of WSL1, 3 bytes will be shared by both of them. For example, I will take one Excel sheet and I'll show you. So first slot, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. This is WS hello 1. 1, 2, 3. WS hello 2. Okay.
okay.
Now WS hello 1 has a length 10, value is mainframe. So each word will go to one slot. MAINFRAMES. And the value for WS hello
Okay.
2 we'll see later on. Now, since
Okay.
WS hello 2 redefines WS hello 1 for x of 3, that means the first three positions for both 1 and 2 will be shared by both of them. The first three positions will be shared. So hello 2 redefines L1 for the first three positions. So when the memory is shared by both of them, then obviously the value also will be shared. So the value for WS hello 2 will automatically become MAI.
Uh,
That is because suppose you and your friend go to a new town and both of you take rooms. You take your separate room, your friend takes separate room. Then whatever belongings you have in your room will belong to you, and whatever things your friend has will belong to him. So because you are staying in separate room, you're staying in separate rooms and your things are also separate. But if both of you share one single room, then the fans, the windows, the doors, the everything whatever is present in the room will be shared by both of you, correct? Since
okay.
WSL1 and WSL2 are sharing the first three bytes, so the value whatever W1 WS hello 1 has will automatically be the value for WS hello 2. So that is the case here. Display WS
Okay.
hello 1, display WS hello 2. When you display WS hello 2, the value for WS hello 2 will come as MAI. Next is move ABC to WS hello 2. Next, what I am doing is in place of WS hello 2, I am moving ABC. A, B, C. So when I change the value for hello 2, automatically it will change the value for hello 1 also because They are sharing the first 3 bytes.
Sure.
So the value for hello1 also will become ABCNFRAMES. So finally, I'm displaying both of them. So I'll show you that. This is source lib1. See, the value for hello1 was mainframes. The value for hello2 also became MAI. When I moved ABC to hello2, the value for hello2 changed to ABC. The value for hello1 also changed to ABCNFRAMES. Got it?
Got it.
This is what is called redefines. Now, redefines has a real-time scenario. This is just an example of how it works. But in real time, what happens is,
Ah,
suppose you have a file structure. Okay. Generally, what happens if there's a file which is coming from client side, we have a definite file structure. Each record will follow the file structure. For example, first 10 characters will be names, then there will be salary, then there will be ID, indicator, address, all of that fixed structure. Sometimes what happens is in a single file we might have two, three types of data, different structures. One may be personal information, one may be professional information, or one may be this type of data, one may be that type of data. Two, three types of data may be there, and each and every data has a different data structure. Okay, for one type of structure, first 10 bytes may be different, second byte may be different. So the data structures will be different, but ultimately all are part of the same file. That time what happens is but anyway we have to define a layout of the file, correct? But
nice.
since the layouts of the records are different, in the layouts of the records are divided into two, three different structures, then how will the normal data structure work? That is when the redefines will work. We have to use redefines. We have to take a group variable, then a sub-elementary variable, and the sub-elementary variable will be redefined by each and every type of layout. Okay. For example, we'll have
Okay.
a 01 WSA, then under which we'll have suppose 02 WSB picture clause x of 10. This x of 10 will define what type of data we are having. And then remaining 70 bytes, suppose picture clause is the normal record. It may have any type of data. So so the input file has 80 bytes, out of which it has been divided into two parts. First 10 bytes will tell us what type of data it is, and second 70 bytes will be the actual data. Now we'll have the actual data. Suppose WSP personal information redefines WSP. I'm not writing everything. Picture clause x of 70. Similarly here also, suppose WS such professional information redefines WSB, like that. Sorry, WSC. So whatever business data WSC has, it can be anything. It can be any type of data. Now each type of data will redefine WSC. Now inside WSP also we have to define the structure for WSP. Inside WSPR we have to define the structure for WSPR. Whatever professional information structure we have to define under this. Whatever personal structure we have to define under this. This is how redefines
Oh,
works in real time.
oh,
Got it?
okay.
This is the structure. So this is the redefined structure, okay? So you have a file WSA, you have a variable WSA. Suppose the length is WSA length is 80, out of which it has been divided into two parts, WSP and WSB. WSP has 10 bytes, which will have client ID, some record type or something, and some flag which will tell you whether it's a personal information or professional information. And remaining 70 is the actual data. It can have personal data also, professional data also. Now WSC defines professional information. So WSC redefines WSB and the structure is this one. Similarly, WSD defines some other information, some address information, suppose. It also redefines WSB and the structure is this one. Like this, you can have hundreds of structures. Each structure will redefine WSB because WSB is generic. It can have personal information, professional information, any type of data that is defined can have, it can have, and all the types of data you can define like this, and you can redefine, you have to redefine every time WSB. And how will you know whether it's a personal information or address information or professional? There will be a flag in WSP. From that flag only you will get to know. Okay.
Okay. If we change WSB means it will affect the C also.
Hmm?
Whatever data in WSB, same in WSC and DA also, right?
See, in WSB, the 70 bytes you can have any data. You can have professional information also, personal also, address also, any kind of data, whatever the client sends.
Okay.
So each type of possibility you have to redefine, you have to write this way. So first of all, this is the professional information, this is the address information. Now professional information structure is this one, but ultimately it has to redefine WSB. And address information structure this one, it also has to redefine WSB. WSB does not define any type of data, it defines all types of data, it can be anything, but each type of data has to be defined below, because if you don't use redefines, the length of the file will become 10 plus 70 plus 70 plus 70 plus 70, it will keep on increasing. Because of this redefines, the
Okay.
length of this file will remain 80, 10 plus 70. This redefines, every time it is redefining WSB, so this value, the length of WSC is not getting counted.
Okay.
58, 59, 64, 65, 70, 80, till 48. Okay, 48, 33. Just an example. This is a real-time example. You have to use this kind of, you will get this kind of files. It's very important. Okay.
Can we run this?
No, this is just a structure. It will not run. This is just a structure of the file. So I have, see, this is wrong
Yes.
actually. I should have defined it under file control and everything. This is just a
Okay.
file structure. I should have defined it under this one, in a copybook. Okay. But I have written in procedure division. This is just for example. Okay. Just for example. It's wrong actually.
We can't see in real time.
I'll show you one program. I have to write one program to show you.
Oh,
This is just I have written to show how it looks like, but don't go by this procedure name, working storage data. Under data division, there will be file control. Inside file control, this should be written. Or you can keep it inside copybook also. The file structure.
oh.
Okay. Now next concept is called renames. Renames is another concept. Now, if you have a variable like this WSLO1, under which there are two sub-elementary variables WSA, WSB. WSA has a value IBM, B has two sub-elementary variables C and D. C has a value mainframes, D has two sub-elementary E and F. E has a value is, F has two sub-elementary G and H. G has a value D, H has a sub-elementary WSI best. Now that what is the value of WS hello one then? Can you imagine?
Maybe a mainframe is the best.
Yeah. But the thing is in mainframe, if you display something, the starting position you can control from where you want to display, and the ending position you cannot control. You don't have control on the ending position. By default, it will go to the last. If you display WSL1, it will start from here, and by default, it will go to the last, and it will display till this point. If you display WSD, it will start from here. It will go till WSI. If you display WSB, it will start from here and go till WSI. So whenever you do a normal display, You can handle the starting position, but you cannot handle the ending position. By default, it will display till the last. What if you want a range from here to here? You want some value from here to here, from WSA to E. Can you get it with normal display? If you display WSA, the value will be IBM. If you display WSB, the value will be mainframes is the best. It will go to the last. If you display
Ah,
WSB, value will be is the best. If you display WSE, it value will be is. But you cannot get a value from WSA to E. This range you cannot get. If you want to
okay.
get those kind of values, you have to use this renames clause. So for renames clause, you have to use 66 level number.
Oh,
I have taken 66 WSJ, renames WSA through G. A through means from A till G, from here till here. What should be the value? IBM mainframes is the. This will be the output. Next, I have taken one more 66 WSK renames WSG through I. That means from here to here, the best. If you do a normal display of G, value will be the. If you display WSH, value will be best. If you display I, value will be best. But if you want from G to I, it's not possible with normal display. You have to use renames clause. So with
oh,
renames clause, you can find a range of values. So after that, I have displayed the normal display WSHello1, then I have displayed WSJ and then WSK. Let's see how it works. IBM mainframes is the best. This is the normal display. This is the normal display. IBM mainframes is the best. WSHello1. Then WSJ. WSJ is A through G. A through G means from here to here. So IBM
oh,
mainframes is the IBM mainframes is the. Next display is WSK. WSK is G through I. G through I is from G till I. The best. The best. This is how it works. This is how, with the help of renames clause, you can find a range of values. It's not used in real time very frequently, but if it is used, you should know how it is used.
ah, okay.
Got it?
Yeah, got it.